We'll work with some messy data to learn how to format it and code the variables properly, create simple frequency tables, and review a few graphing techniques to help us better understand our data and look at many variables at once. We'll use data from a questionnaire administered to undergraduate students aimed to understand their preferences for learning specific technologies as part of their education. This survey produced a pretty complex and messy data set, which makes it difficult for us to work with. Let's take a closer look. You'll notice this data set has 39 observations and 11 variables. Take note of what you see as messy with this data. Is there a lot of text? Long column names? Maybe some missing values? Also, review the columns that correspond to the responses for questions 1 through 4. These questions require a response on a 7-point Likert scale. However, for question 1, the responses are in text, whereas in questions 2, 3, and 4, they're all numeric. Remember, we need our data in a numeric format to perform any kind of calculation. Also, it's difficult to work with column names that are really long. The first thing that we need to do is recode all of those 11 variable names. We can use the names function to rename each of the columns in the undergrad dataset. The names need to be written in the order as the columns appear in the data frame. So we'll start out by just creating a simple R markdown document. Then we're going to use the names function to rename our columns. Let's view the results. To make your data manipulation and analysis of the undergrad data frame a little bit more efficient, use the attach function. The attach function enables you to work with the variables of the data frame directly without explicitly referencing the name of the data frame. It saves the reference to the data frame in your R path. For example, to view the data in the Excel variable of the undergrad data frame, you'd normally have to enter undergrad $Excel. Try using the attach function now. Simply say attach and then pass in the data frame name, which is undergrad. Then, as I mentioned before, we can reference that Excel variable directly by just typing Excel. Let's construct some simple frequency tables and histograms. A typical data analysis task is to construct a frequency table or cross-tabulation of one variable to another. Let's look at the variables IS course and CS course. These variables refer to the likeliness that a respondent will take another course in the field of information systems or computer science. We are selecting these two variables because, as we saw before, the responses to the questions were coded as numbers. To be sure, we can check the name of the variable type using the class function. We see that it's of type integer. Let's create a simple frequency table. A simple frequency count of the number of respondents per response category will help us analyze the results. We can use the table function to tabulate the results of each variable, just by saying table and the variable name. To interpret these results, look at the first row for each response type. This is a scale that includes the integers 1 through 7, representing the likelihood that the respondents will take a course in either computer science or information systems. A response of 1 is extremely unlikely, whereas a response of 7 is extremely likely. Now we can visualize the results of a frequency table using the hist function for histogram for further analysis.